Today we will look at adding algebraic terms. And in the process, we will review adding integers, decimals, and fractions. So let's get started. Quick vocabulary reminder. Each of these items that are separated by addition or subtraction, as we'll see in the next lesson, these are called terms. So today we're going to work on adding terms. And when we add terms, they must have the same variable raised to the same power. In today's lesson, that will not be a problem. All of them will be the same variable raised to the same power. So in this case, we have 3x plus x. So we have the variable x raised to the first power in the first term, and the variable x raised to the first power on the second term. So we can add these terms. We can add these terms because they are considered like terms. Now 3x, that is 3 x's. So we have 1, 2, 3 x's here. And then we're going to add one more x. Well, that's 4 x's, and we write that as 4x. So 3x plus x is 4x. Now let's look at some examples with decimals. So in this example, we have 0.6y plus 0.2y. So 0.6, or 6/10, that is the fraction 6 over 10. So if we had y, and y is this entire section here, and we split it into 10 equal parts. Of those 10 parts, 6 of them would be included, and I've shaded those 6 blue in this example. So 0.6y is represented by these blue bars within the y. And then same with 0.2y. Well, that's 2 over 10. So 2 of the 10 sections would be shaded blue. When we add these sections together, we get 0.6 plus 0.2. Well, that's 0.8. So now we have 8 out of 10 sections shaded, and the answer is 0.8y. Now let's look at fractions. So once again, we have 1/3 x plus x. And we can represent x, an entire x, with this bigger rectangle. And since we have the fraction 1/3, we're going to divide it into 3 sections. And I've done it for both the 1/3 x as well as x. So for 1/3 x, only one of those 3 sections is shaded. I shaded orange in this example. For x, well, that's the same as 3 over 3. So all 3 sections in this case are shaded. We add these up, we end up with 4 sections that are shaded. These 4 sections represent 1/3 of x, so we have 4/3 x as our solution. We can also add this just by finding a common denominator, like we've always done when we added fractions. So in this case, 1/3 x, we can write this as x over 3. Plus, and then x is going to be x over 1. Now in order to add these, they need a common denominator. A common denominator of this is 3. A fast way of finding at least one common denominator is just multiply the 2 denominators. So 3 times 1 is 3. It may not get you the smallest one, but it will get you a common denominator. So in this case, there's no change in the first fraction. In the second fraction, we need to multiply both the top and bottom by 3. That's going to give us x over 3 plus 3x over 3. Now we have a common denominator. We can add the top and the bottom. 3x plus x is 4x all over 3. So in the second problem, we have 1/2 y plus 1/3 y. Well, let's find equivalent fractions. So 1/2 y, an equivalent fraction, is 3/6. So we can take y and split it into 6 even pieces. And when we do that, 3 of those 6 will be shaded. So this represents 1/2 y partitioned or cut into 6 equal pieces. Well, for 1/3, an equivalent fraction is 2/6. So once again, we take y, it's split into 6 even pieces, and 2 of them will be shaded. When we add these parts, we end up with 5 shaded regions. The answer is 5/6 y. Adding these using standard fraction addition instead of the bar model, we find a common denominator. A fast way to find a common denominator is to multiply the two denominators together. That's going to give us 6. So in order to make a 6, we need to multiply by 3. So we're going to multiply both top and bottom of the first fraction by 3. And for the second fraction, we're going to multiply by 2, both top and bottom. So this is going to give us 3 times 1 is 3. 3 times 2 is 6. So 3/6 y plus 2 times 1 is 2. 2 times 3 is 6. 2/3 y. We can also write this as 3y over 6 plus 2y over 6. We add our numerators. That's going to give us 5y all over 6, which is the same thing as 5 over 6y. Now let's practice without the bar model. Again, in all the examples you see today, these are going to be like terms. So we're going to have the same variable raised to the same power. So we're combining like terms. So now we have 13x plus 5x. We add these coefficients. That's going to give us 18x. 2y plus 0.2y. This is 2.0 plus 0.2. We add that up, we get 2.2. So this is 2.2y. And then we have 1.3z plus 2.4z. Go and add those coefficients. And 2.4. That's going to give us 7. We bring down that decimal, and then 3. So we get 3.7z. Now if you notice, in each of these cases, I'm just looking at the coefficients, kind of ignoring that variable for the time being. And this is because we can take something like 13x plus 5x, and we can factor out that variable. We can pull it out, kind of doing the reverse of the distributive property. And I factored out the x. They had x in common, so I could pull it out. And then, when we do order of operations here, we would do the items within the parentheses first. So that's going to give us x times 18. And now we kind of have multiplication. This is 18 times x. Order doesn't matter in multiplication. It's commutative. So I can change this to 18x, which is the answer we got. Again, this means 18 times x. Same with the second problem. We could factor out that y, and that gives us 2 plus 0.2. So when I add algebraic terms, again, the first thing I'm verifying, I'm checking to make sure it's the same variable raised to the same power. Once I see that they are like terms, and that I can add them, I then add the coefficients and bring down the variable. Let's practice a few more with fractions. Okay, so this is x plus 1/4 x. I'm going to go ahead and put this as a fraction, so that's x over 1 plus x over 4. So when we see something like this, this is 1/4 times x over 1. So that's x over 4. Common denominator is 4. So now we have 4x over 4 plus x over 4. Two fractions with a common denominator, so we add the numerator. We get 5x over 4. So we have 2/5 y plus 1/2 y. So 5 times 2 is 10. A common denominator is 10. And in this case, it's also the least common denominator. So in order to change 5 into 10, we need to multiply both the numerator and the denominator by 2. So an equivalent fraction here is 4/10 y plus, and then in order for the 2 to become a 10, we multiply by 5. So that's going to give us 5/10 y. Again, remember these y's are in the numerator. They're up top. Or we can view these as y over 1 if you'd like. So in a sense, we have 4y over 10 plus 5y over 10. We add these together. 4y plus 5y is 9y all over 10. And then finally, we have 1/3 z plus 0.5 z. So we have a mix of fractions and decimals. Typically, we don't mix fractions and decimals, but it's perfectly valid. And what we'll do is we'll convert one to the other. And depending on what the numbers are, will determine which way I convert the fraction to the decimal or the decimal to the fraction. When I see this fraction here, to convert 1/3 to a decimal, well, that's going to be 0.3333, and that 3 is going to continue forever. So it's 0.3 with a bar across the top. So that's difficult to convert to a decimal and to work with conveniently. So instead of converting 1/3 to a decimal, I'm going to convert 0.5 to a fraction. So we have 1/3 z plus, now 0.5 is 5/10. We can simplify this a bit. This is 1/3 z plus, well, there's a 5 all over 5 times 2, so this is just 1/2. And if you recognize that 0.5 is the same as 1/2, that's good. If not, write it as 5/10 first, and then simplify that fraction down. So now we have 1/3 z plus 1/2 z. Common denominator will be 6. So this is 2/6 z plus 3/6 z. We add those together and we get 5/6 z. Not quite sure if you noticed, but when I make my z's, I tend to put a bar across it. That distinguishes my z's from my 2's, which sometimes look a lot alike. And as you're writing out math, it's important to make sure you know which is a number and which is a letter and distinguish between them, depending on how neat your handwriting is. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 3 problems. So once again, we are combining like terms. All of the terms have the same variable raised to the same power. So now we will add these coefficients. If you need to, go ahead and just write this out using arithmetic. So 26 plus 15, 6 plus 5 is 11, carry that 1, that's going to give us 41. Now in this second problem, we have 3 terms, but again, they're all the same. They're all like terms. They all have the variable y raised to the first power. So we'll use order of operations to solve this. All we have is addition. So we're just going to add from left to right. So 0.4y plus 1.3y is 1.7y. And then we bring down that 0.1y. And then we add these two, and we get 1.8y. Now we have a fraction. We have 1/4z plus 5/6z. Again, a fast way to find a common denominator is to simply multiply the two denominators. That's going to give us 24 in this example. But the least common denominator in this case is 12. So 4 goes into 12 3 times. 6 goes into 12 2 times. And the result here is 13/12 z. You can leave this as an improper fraction, or you can write this as 1 1/12 z. And if you leave it as an improper fraction, you can also write it as 13 and put that z up in the numerator, all over 12. So all three of these are equivalent answers. They're the same. Keep practicing adding algebraic terms, and I'll see you in the next video.